Hello everybody. So this is our first video lesson and we're going to go ahead and jump into the math. This would be notes number 1 and the title is Number Sets and Properties of Real Numbers. So here's the plan. We're starting chapter 1, but chapter 1 is a whole lot of review topics that you've seen in Algebra 1, just a whole bunch of different things put together, and we're not going to take the time to go over every individual topic in the chapter. We're just going to kind of take a couple days, do an overview, and I will mention the main ideas. So some of the things that are the most important in chapter 1 are understanding the vocabulary associated with number sets and properties of real numbers. So we're going to go through and write some definitions and do some examples. Okay, so natural numbers are also known as the counting numbers. So if you think about when you learned how to count, chances are you started with 1. So you had 1, 2, 3, etc. So to define the natural numbers, what we're going to do is just use set braces, the squiggly braces, and then we start with 1, 2, 3, and then we put 3 dots indicating that we keep going according to this pattern. Okay, next let's define the whole numbers. So the whole numbers are very similar to the natural numbers, except that we include 0. So the whole numbers would be the set of numbers 0, 1, 2, 3, etc. Okay, and remember that you are writing this in your notebook or on a piece of paper if you don't have your notebook yet, and you can just tape that piece of paper into your notebook when the time comes that you get it. All right, let's move on to integers. So at some point you learned when you were growing up that not only are there counting numbers and not only does the number 0 exist, but you could have the opposites of numbers. So instead of going forward, you could go backward. Instead of going up, you could go down. So instead of going positive, you could go negative. And so the integers are the whole numbers and their opposites. And the way we describe that would be ... -3, -2, -1, 0, 1, 2, 3, etc. The whole numbers and their opposites. Okay, now at some point you also learned that there's such a thing as a fraction. So you could have half a cookie or 2/3 of a piece of pizza or something like that. And so if we want to represent the numbers that we often think of as fractions, we call those the rational numbers. Now, fractions is a bit too casual of a definition for us. So in Honors Algebra 2, we do like to be a little bit more rigorous and we like to be precise in our mathematical notation. And so instead of just calling them fractions, what I want you to do is write your definition like this. Rational numbers are numbers of the form a over b, where a and b are integers, and b is not equal to 0. Okay, so we could have 1/4, we could have 7/13, we could have -3/100, we could have 7. 7 is 7 over 1. That could be written as a over b. We could have -3. -3 is -3 over 1. -6 over 2, etc. So if you can write it as a fraction, a over b, where a and b are integers and b is not equal to 0, then it's rational. So even if it doesn't currently look like a fraction, if it's just the number 5, the question is, can you write it as a fraction? Sure, 5 over 1, 10 over 2, etc. So it is rational. Well, why can b not be 0? What happens if you divide by 0? Exactly, you're right. It's undefined. Division by 0 doesn't make any sense in mathematics, and so that's why we have to say b is not equal to 0. Okay, let's continue with our definitions. Now we have irrational numbers, and if you think about the prefix ir, kind of like irregular, Irrational just means not rational. So we have a pretty pathetic and unsatisfactory definition for irrational numbers. These are real numbers that are not rational. So they cannot be written as a ratio of a over b, where a and b are integers and b is not equal to 0. Okay, so we just say they're not rational. So what are real numbers? Well, real numbers can be thought of as numbers that can be mapped to a number line. And real numbers consist of all of the rational and irrational numbers. If it's rational, then it's real. If it's irrational, then it's real. Nothing else is real. Now, earlier we were talking about how in the definition of rational numbers you can't have 0 as b. So that's still true for real numbers. You can't have 7 over 0 or 5 over 0 or something like that. That is not real. It's not rational, it's not irrational, it's not real. It's just not considered a defined number at all. So it does not fit in any of those categories. Okay, so what I think we'll do next is kind of make a diagram that shows how these number sets fit together. You have sets and then you have subsets. So what is a subset? A subset is a set that's a smaller, or it could be exactly the same size, I suppose, but its elements reside in the larger set. So let's make a tree diagram. If you think about the number sets that we were just looking at, the largest number set that encompassed other number sets was the set of real numbers. And that branched into the sets of rational numbers and irrational numbers. So if you think of real numbers as the umbrella, rational and irrational are both inside that umbrella. Now, rational numbers could also be broken up because we have some rational numbers that are also integers and others that are not. If you have 5 over 1, it's rational, but it's also an integer. If you have 5 over 2, it's rational, but it's not an integer. I'm just going to call these the non-integers. Now, integers could also be broken up. Remember, we said that integers were the numbers that were the whole numbers and their opposites. So we could list the whole numbers as a subset of the integers. What are we going to call their opposites? So those would be the numbers -1, -2, -3, etc. I guess we could just call those the negative integers. They don't have a special name. They're just not whole numbers, but they're still integers. And then we could break up the whole numbers. If you think about the counting numbers or the natural numbers being a subset of the whole numbers, 1, 2, 3, etc., then what else do we have that's a whole number? 0. Okay, so there is our diagram which shows all the sets of numbers we talked about earlier and how they relate to one another. So let's do a little bit of a practice exercise. Okay, I have some always, sometimes, and never questions. And so we're going to think these through and think about whether we should say always, sometimes, or never. You do not need to write these in your notes. An integer is a rational number. So can you take an integer and write it as a ratio of one integer over another? And if you look back at the tree diagram, are integers under rational numbers? They are. So, an integer is a rational number, always. Five over 1 is the integer 5. 17 can be written as 17 over 1, etc. How about the next one? A rational number is an integer. Is every rational number an integer? Think about that. 6 is a rational number. It's an integer. 6/4 is a rational number. It's not an integer. So this one would be sometimes. A whole number is a real number. Is every whole number real? Let's look back. Are whole numbers inside the umbrella of real numbers? Whole numbers under real numbers? Well, yes, they are. We can see that. Okay, so this would be always. A real number is rational or irrational. Remember, we said that's what the real numbers were. They're made up of rational and irrational numbers. So that one is always. Now, what if we combine numbers? The product of two integers is an integer. What do you think? You can think of some examples. Product, remember, means you're going to multiply them. So take an integer, 5. Multiply it by another integer. 12. Do you get an integer? Try it again. Take an integer. 0. Multiply it by another integer. -17. Do you get an integer? I think you're probably finding that that is always. How about the quotient? The quotient of two integers is an integer. You're going to divide. Suppose you have 5 divided by 1. Integer divided by integer. Is that an integer? Yes, it is. Suppose you have 5 divided by 2. Integer divided by integer. Is that an integer? No, it is not. So this one is sometimes. The quotient of two real numbers is a real number. Well, let's look at some examples. 16 is a real number. 3 is a real number. Is 16 divided by 3 real? 16 divided by 3 is rational. And rational numbers are real, so yes. 16 is a real number. 0 is a real number. Is 16 divided by 0 a real number? No. Division by 0 is not allowed. It's not defined. So this one is going to be sometimes. Okay, here's what we're going to do. I'm going to go ahead and stop this video, and at the end, you're going to see a couple of extra always, sometimes, never questions that you can answer. And then there's going to be a part 2 video where we address the second half of today's lesson.